Hello boys and girls, so in this video we are going to discuss about the motion of charge in a uniform electric field. So we learned this before. We know that a charged particle in electric field will experience electric force, whereby the electric force is given by Qf equal to Qe. Okay, so the charged particle will accelerate as detected by the Newton's second law, F equal to ma. So according to Newton's second law, if there is a net force experienced by a particle, the particle will accelerate. So same goes for charged particle in electric field. Since it experience net electric force, so it will experience acceleration. So if we apply Newton's second law, F equal to ma. So the F here is the electric force QE. So I put it in. So QE equal to ma. So I can get the acceleration, the magnitude of the acceleration for the charged particle in electric field will be equal to QE over m. So this is the equation we calculate the magnitude of the acceleration for a charged particle experienced in electric field. Q is referred to the magnitude of charge, E is referred to the electric field strength, M is referred to the mass of the charge. Okay, so when the charged particle accelerates in electric fields, then it might move. So how the charged particles are going to move in uniform electric field? There are various situations. So we are going to consider the situation one by one. So let us see for the first situation. We go for the situation 1, whereby our charge is moving parallel to the field. So if we have a charged particle with velocity u, for example, we have charged particle with velocity u enter parallel to the field. The charge is enter parallel to the field. Okay, so the charge is enter parallel to the field. Tengok, the direction of motion of the charge is parallel, selari dengan electric field kita. Selari dengan electric field kita. So what will going to happen? So we understood when the charge move in electric field, it experience electric force. So untuk charge positif ni, dia akan rasa electric force ke bawah, menarik dia ke arah plate negatif. So for this charge positive, it will experience electric force downward, straight downward. Fi. Okay, I denote by F. Same go for the negative charge. It experience electric force, but the electric force will be acting upward. Why? Because charge negative attract to plate positive. So for charge negative, it experience electric force upward. So the electric force that you will find out that the electric force acting is parallel to the direction of motion. Okay, so arah force ni adalah selari dengan arah pergerakan. Jadi for the force that same direction as motion, we will find out that the charge will accelerate in straight line. If the electric force is acting opposite in direction with the motion, contohnya macam charge negatif ni, then the charge particle will decelerate in straight line. Okay, so maksudnya charge tu akan bergerak dalam straight line. Sama ada accelerate ataupun decelerate. So since the charged particle move in straight line, then we can apply the kinematic equation lah, whereby we might apply S equal to ut plus half at squared if I want to find the distance traveled by the charge in the electric field, or if I want to find what is the velocity. Maybe I would like to find when the positive charge reach the plate negative, what is the final velocity here. So how I'm going to find the final velocity when the charge reach the plate? So I might use the kinematic equation V equal to U plus AT, or V squared is U squared plus 2AS, whereby the acceleration experienced by the charge can be calculated using QE over M. Okay, so why we can use kinematic equation? Because the charge is moved in straight line. So, untuk situation pertama, I repeat for first situation, if our charge is moving parallel to the field, our charge is moving parallel to the field, it will whether accelerate in straight line or decelerate in straight line. Bergantunglah sama ada force tu searah dengan pergerakan ataupun menentang arah pergerakan. Okay, so that one is the first situations. Then we might have the second situation. Kita boleh ada situation kedua whereby our charge is moving perpendicular to the field. If our charge is moving perpendicular to the field, what are going to happen to the motion of charge when it enters the uniform electric field? So, class, the charge particle of velocity u, for example, I have charge particle with velocity u, it enters perpendicular 90 degree into the electric field. Contohnya macam charge negatif ni, dia masuk dalam electric field secara perpendicular. See the direction, see the direction of motion, the velocity, arah velocity adalah 90 degree perpendicular to the field. This is our electric field. Electric field is acting from straight downward, but our charge is moving from left to right horizontally. So the direction is 90 degree. Okay, the direction is 90 degree. Our charge is moving perpendicular to the field. So as long as the charge enters the electric field, it experiences electric force. So we will find out that for charge positive, it will attract, it will experience electric force downward, tarik ke plate negative. For charge negative, it experiences upward electric force. Upward electric force, okay? So the electric force acting is perpendicular to the direction of motion. You perhatikan, electric force tu adalah along y-axis. Tapi pergerakan charge adalah secara horizontally, sepanjang pasi x. So the electric force is perpendicular to the direction of motion. So this electric force will causes the charge particle to move in parabolic path. It will move in projectile motion. Okay, so for charge that moving perpendicular to the field, due to the force acting, contohnya charge negatif ni, kalau kita perhatikan charge negatif ni, kalau diperhatikan untuk charge negatif ni, dia nak gerak ke depan. Pergerakan dia ialah ke depan. Tetapi ada force, electric force tarik dia ke atas. Electric force tarik dia ke atas. So apa jadi kepada pergerakan charge negatif ni? The charge negative will doing projectile motion. It will deflect upward lah. It will deflect upward. Same go for this charge positive. Same go for this charge positive. Kalau diperhatikan, pergerakan dia ke depan, tetapi ada electric force tarik dia ke bawah. So apa jadi kepada pergerakan charge positif ni? Dia akan deflect ke bawah, lakukan projectile motion, deflect ke bawah. So which plate the charge deflect? It depends whether it's charge positive or charge negative. Okay, contohnya teacher ada charge positive. Okay, this charge positive is going to move horizontally enter the electric field macam ni. So, perhatikan pergerakan charge tersebut bila dia gerak secara horizontal, kerana electric force dia akan di-attract ke atas. Okey, dia akan deflect ke atas. Teacher reset, kita tukar jadi charge negatif pula. Kita perhatikan pergerakan dia. Bila dia masuk dalam electric field, dia akan deflect ke bawah. Kenapa dia deflect ke bawah? Sebab dia akan attract ke plate positif. Alright. So this is what I refer to this statement lah. Which plate it depends whether it's charge positive or charge negative. So class, since the charge is doing projectile motion, so at any point the motion is combination of horizontal and vertical motion. So kita boleh apply kinematic equation in order to determine the final velocity, the distance travel and also the deflection. But we have to apply the concept in projectile motion lah, whereby we have to consider the x motion and y motion separately. Okay, so we are still using the kinematic equation. So for the case of electron and proton which the mass is too small, sometimes we can ignore the weight lah. So maybe you ask, hey teacher, are we going to consider the weight of the charge? So for the case of electron and proton, because the mass is too small, see? The mass of proton is 1.67 to the power of negative 27. The mass of electron is 9.11 to the power of negative 31 kg. The mass is too small, so we can ignore the weight. But for the charged particle that have mass that is not negligible, kalau charged particle tu terlalu besar, di mana mass dia kita tak boleh abaikan. Contohnya charged particle tu mass dia 2 gram. Then kita tak boleh abaikan weight. Then we need to include the weight in the resultant force acting lah. If we cannot ignore the weight, so we have to consider the weight lah in our resultant force acting when we do the calculation for acceleration. Okay, when we do calculation for acceleration. Then class, we might have the third situation whereby we have a stationary charge. Maksudnya, very starting, charge tu kita pegang. Kita pegang charge tu, we have a charge particle, we held set stationary in the electric field, and then when we release, what are going to happen? So when we release, what are going to happen? So what are going to happen? It depends on the electric force acting lah. It depends on the electric force acting. Contohnya, charge positif, dia akan rasa electric force ke bawah. So, apa jadi? When I release the charge, when I release this charge positive, it will accelerate downwards lah. Dia akan accelerate straight downwards. Follow the direction of force. Follow the direction of force. Same go for this charge negative lah. So, this charge negative, bila saya pegang dalam electric field, dia letak dalam electric field, dia rasa electric force. Charge negative, electric force dia straight ke atas lah sebab dia akan attract ke plate positif. So, this is the electric force acting. So, upon release, bila saya release kan, saya lepaskan charge negative ni, what are going to happen? This charge will accelerate lah in a straight line lah, follow the direction of the net force lah, the electric force. Okay, so the charge negative will accelerate upward lah upon release. The charge positive, upon release, it will accelerate downward lah. So, acceleration tu ikut arah electric force kita lah. So, kita dapati dia melakukan straight line motion, so we still can apply the kinematic equation lah for this situation. Then we move on to the last situation. For the charge in dynamic equilibrium, what is meant by dynamic equilibrium? What is meant by dynamic equilibrium? For example, this one, I have a uniform electric field. Then I have a charged particle, negatively charged. It entered perpendicular 90 degree into the electric field. It entered perpendicular 90 degree into the electric field. So once the charge negative enter the electric field, bila charge negatif ni masuk dalam electric field, dia rasa electric force. So, dia rasa electric force ke mana? Dia akan ditarik ke bawah ke atas? Okay, so kita tengok. Dia charge negatif, so dia akan attract ke plate positif. So, upon enter the electric field, dia rasa electric force upward. F. Okay? F. Electric force upward. So, dia rasa electric force upward. Anyhow, if the charge particle, the mass is large, kalau charge particle ni, mass dia large, then it will have weight that we cannot ignore. Dia akan wujud weight yang kita tak boleh abaikan. So, weight kita tahu, weight is always acting downwards. So, untuk charge particle ni, dia ada weight acting downwards. W. Weight. So, if the weight balance this electric force, kalau weight tu, nilai weight ni balance sama dengan electric force ni, then the charge, we said that the charge particle is in dynamic equilibrium. So, F. So, kalau F minus W, kita dapati nilai dia kosong, then kita katakan charge ni dalam dynamic equilibrium. Tu summation force equal to zero. Kalau kita, maksudnya kalau electric force kita 3 Newton, weight kita pun 3 Newton, then resultant force, summation force dia akan dapat kosong, dan kita kata charge particle ni dalam dynamic equilibrium. So, kalau charge particle tu dalam dynamic equilibrium, if the charge particle in dynamic equilibrium, what are going to happen? It will move in straight line lah across the field. So, apa akan jadi kepada pergerakan charge ni? Kalau F dia balance dengan weight W, then charge tu tidak akan deflect lah, tapi dia akan gerak secara straight line across the field. Okay, dia akan bergerak secara straight line across the field. Berbeza dengan yang atas, berbeza dengan yang atas ni, untuk yang atas ni, kerana the only force acting is F, so charge ni akan deflect lah ke atas. Macam tu, dia akan lakukan projectile motion. So, pergerakan charge tu macam mana? It depends lah kepada situation lah. Alright, so this is the 4 situation we have when a charge enter uniform electric field. So later in tutorial session, we are going to apply the concept lah. Kita akan apply concept. So for this concept, before you enter the tutorial class, you might try question 12 to question 15. Okay, so using this concept we learn, you can try tutorial 1, question 12 until question 15. And then we will continue the discussion how to apply this concept in our tutorial session. So, with this, we end our discussion on all the concept in topic 1. So, I shall see you on topic 2. So, topic 2, we are going to have capacitors. Okay, we are going to move on to a component that can store charge. We call it as capacitor. Okay, so I'll end my video here. Thank you for your focus. I'll see you on the next topic. Thank you, class.